headphones.
Hello and welcome to our angles and polygons video.
Turn the music up in the headphones.
So, for this video, we are going to talk about polygons and triangles. But I will also be working with Mr. Barnett. Hey, Mr. Barnett. Ha ha ha. That's funny. Well, on this video, we're going to mix in working with making a study guide and learning the last kind of final geometry topics that will help you for FCAT. And what you'll see is things that are emphasized, like this, are what we're going to talk about, and they'll be in bold. So those are your key points to maybe if you want to write down ideas or decide or help you answer some of the questions that we're about to do. So our first kind of thing that you need to know is the sum of the measures of the interior angles of a triangle equals 180. What does that mean? Well, the first thing we need to think of is when you have a 360 dunk. When you have a 360 dunk, you spin around in a full circle. So if we were to cut that circle in half, it would be half the degrees. So a 360 dunk is a full circle, 360 degrees, and half of that would be 180. That is important because if you take any triangle in the world and just like this picture kind of cut off its corner angles, and we take all these angles and kind of line them up point to point, what we find is that they make half of a circle. And half of a circle is again 180 degrees, which is why all the angles in a triangle add up to 180 degrees. So, with that being said, we can use this information to find missing angles of a triangle. Notice that when you're looking for angles of a triangle, they are inside the triangle. We're not talking about side lengths. Like if we were talking about Pythagorean theorem, we were talking about inside the triangle. So in this first example, we have a triangle with an angle of 70, 40, and a missing angle. To solve for that missing angle, we can use just a little bit of algebra. Knowing that all the angles in a triangle add up to 180, we can just add 40 plus 70 plus our missing angle, which we're going to call x, and we know that they add up to 180. So we can solve this equation. I see like terms here, 40 and 70. They add up to 110 plus x equals 180. Sorry about my handwriting. I'm writing on the edge of the screen. Okay, so now we want to get that x by itself, so we just do the opposite. Subtract 110 from both sides. And we get 180 minus 110 is 70. So that means our missing angle is 70. Notice that if this triangle is 70, that means two angles are congruent, which means the sides across from them are congruent. And this is an isosceles triangle. Now, I'm going to tell you to hit pause. Yes. Hit pause. Take a second to look at the other problem before we try to tackle this problem. So, hit pause, and we'll move on to the next slide after we're done. Pause, pause. Are you done? That was great teaching, Mr. Barnett, don't you think? I agree. And here's your next problem. Using the same steps that we did last time, solve for the missing value of x. For right now, hit pause. Pause. Oh my gosh, Mr. Barnett, it seems so easy when you do those problems. I bet all of your students are going to get those kinds of problems correct on the FCAT. So, time to take a processing break. Look at this cute little whatever. And time to process. Okay, the next thing that we need to look at is we're looking at polygons. And polygons are just like shapes, closed figures. And when we look at polygons, realize that they can be fitted together to form triangles. And there are always two less triangles than sides to a polygon. What do you mean by that? Here's some polygons. And I'm going to divide these polygons up by simply placing a point at one of the corners or vertex and connecting it to all the other corners. And as you can see, if those were connected perfectly, the ones on the side here wouldn't do anything. But when I do that, I have divided this into two different triangles. So that's what I was talking about when I said the polygons can be divided into triangles. I'm going to do the same thing with this figure and this figure. Okay, so why is this important? Well, we want to know about the angles in these lines. They're not perfect, but you get the idea. If we want to know about the degrees inside these polygons, so what these angle measures are, or if we want to know about the sum total of all these angle measures, we could just look at the triangles that are formed when you connect the vertices. So for example, this four-sided figure forms two triangles. Well, if there are 180 degrees in this triangle and 180 degrees in this triangle, that will help us find the sum of the measures of the interior angles. Okay? And I'm not sure if you knew this, but there is a formula on the very bottom of the front of your reference sheet. Mr. Barnett, show them. I will hit pause. That's so easy to find. Oh my gosh, it's so easy to find. Anyways, you can use that formula to solve problems like this. Or just think of what we have. So if this is 180 plus 180, the total of this polygon with four sides is 360. Remember what we said, that the number of triangles is always 2 less than the total number of sides. So if we have 1, 2, 3, 4, that makes 1, 2 triangles. There are 7 sides of this triangle and 1, 2, 3, 4, 5 triangles. 8 sides here. 1, 2, 3, 4, 5, 6. 6 sides. So if we were to find the sum of all these angles, so if we want to find the sum of all the angles in this polygon, we just need to remember that for every triangle we have 180 degrees, and we can figure out the number of triangles within the polygons. Alright, and then of course here we go, that easy to find formula. Use 180 times n minus 2 equation to find the sum of the measures of all the angles of a polygon, if n equals the number of sides of a polygon. So in this equation, n is the number of sides. Like we said, it's always 2 less than the number of sides. Alright, use that formula to find the sum of the measures of all the angles, interior angles, in these polygons. You can skip this one because we already found out that this is 360. What about those? Alright, and then the last part of this is once you have found the sum of all the angles by doing 180 times the quantity of n minus 2, if you want to find the measure of any particular angle of a regular polygon, and a regular polygon means all the angles are the same, we can simply just divide by the total number of sides. That's useful for problems such as this. Lou is studying the design of a honeycomb. The honeycomb design is made up of regular hexagons, key word there, as shown below. What is the measure of degrees of angle A? I will let you and Mr. Barnett talk about this one. Hit pause. Alright, time for a processing break. What did we learn? Look at those penguins. Next, we need to learn about angles and transversals. And a key concept is the vocabulary word supplementary and complementary. Supplementary angles are two angles that add up to 180 degrees. Complementary angles are two angles that add up to 90 degrees. Here's a little memory trick. See that S, if I draw a line through it? Kind of looks like the 8 in 180. Supplementary, 180. See this C? I'm going to draw a line here. Make kind of a 9, like in 90. Complementary in 90. That's how you can remember that. And that should help you answer two problems such as this. So, you guessed it, time to hit pause. Mr. Barnett, do your students always get these problems right? Wow, they sure are smart. Ha ha ha. All right. Learning this, or knowing what we just learned, we can use that for problems such as this. It also relates to triangles, so it kind of connects the last two lessons. So, solve for x. Did you get it right? I bet you did. Next thing we need to know about a few vocabulary words here. First, vertical angles. Vertical angles are congruent. And if you were to draw vertical angles, they look like this. And the two vertical angles that are across from each other will be congruent, just like these will be congruent. You can think of like what I said before, they're like scissors. If you open scissors really wide, then this angle below it is going to be really wide. If they're really close, then the angle below is going to be really close. So vertical angles are always congruent. Corresponding angles are congruent. Okay, so we'll look at what corresponding angles look like. Corresponding means in the same position. And the final thing, if parallel lines are cut by a transversal, the measures of angles are either congruent to a given angle or supplementary to it. So we already know what supplementary means. It means it adds up to 180. We'll need that to solve the next problems. Okay, so what do you think? What does all this mean? And our last problem when we're dealing with angles and transversals, in the figure below, lines M and N are parallel. Two transversals intersect on N, forming several angles as shown on the diagram below. What is the measure of angle X? That's a good one. Well, Mr. Barnett, it's all you. I'm sure these great students of yours will help figure out these problems, and they're all going to ace the FCAT. Have a great time solving these math problems. Bye-bye.